Welcome everybody. This is a quick video to show you how to set up an exemplary data table for your lab experiment in Google Sheets. So a data table like this is what we're aiming for. We're going to start with a blank sheet, all right? So first, my left column, I've just set up trial number to make sure that I'm following that 5x5 rule. You're not actually going to use this data when you set up your data table. It's just a useful thing to have here, right? If you come up here to view, and you can go to freeze and tell it how many rows you want it to freeze, 1 row, 2 rows, or up to wherever your cursor is. That's how you can keep that the top row of your spreadsheet so that it's always visible, right? No matter how many different rows you've got. So my first column there is simply the number of trials. I'm not actually going to use it in my data, but what I want here, this is a physics investigation looking at the impulse involved in traffic accident. So one of my control variables was the mass of the vehicle I used. So I know that I measured that mass using a digital balance in class. That's what determined my inaccuracy here, right, or the uncertainty in this measurement. So the way I'm going to put that in here, right, I know that this is mass, right, and I've bolded it there. So then I've written that, then I'm going to hit Command B to turn off the bold. Then I use a Mac, so I'm going to hit Command Return, and that's going to give me a new line within the same cell. Then to make that significantly smaller, I'm going to change my font size from 18 to 12, and I know that my accuracy here, my imprecision here is going to be plus or minus 0.001 kilos, right? And then I hit enter. And so now I have a column heading and it tells me every single thing in this column is a measure of the mass, and it's measured to the nearest 1,000th of a gram, or the nearest milligram, because that's the unit of measurement that was on my digital balance in my classroom. So now I'm simply going to copy all of my data. Hopefully you've set up a data table either in your notebook or on a blank spreadsheet that you're using, and I'm going to paste it all in here. Now you notice, because this is a controlled variable, I use the same vehicle for every single trial. All of them are 239 grams, or 0.239. Notice in the cells, there's no text in here other than the number, right? You don't need to put kilos in here in any of these cells because you've listed it here at the top of the column. All right, there's our control variable. Now, the independent variable in this investigation was the length or the depth of the crumple zone that we put on the front of the car. So we measure that. Here's our crumple zone. I label it crumple zone. Again, I hit Command Enter to get that new line. Then I'm going to turn off my bold. I'm going to make it a smaller font. And sometimes you might have to do that after you type in the numbers, because if you notice, it keeps coming back. In my crumple zone, I measured in meters. I measured it to the nearest millimeter. Right? So here I'm going to come in as 0.01. I'm sorry, that's the nearest centimeter. Right? I can highlight that, turn off the bold. I'm going to turn it down to 12 to make it a little bit clearer. And then I'm going to bring my data in. Do I have all of it there? It looks like I do. Copy. Right? So here you go. I've got all my data there, and I don't want any colors in there. All right, now if you'll notice here, this says 0.01 meters, and all of my numbers here are to 3 decimal places, 2 and 3. You don't want to mismatch here. So if what I was using was a simple meter stick that showed individual millimeters on the meter stick, this should be 0.01. That's 3 decimal places, and it matches this as 3 decimal places. If I simply were looking at the number of centimeters, then all of these values are too precise. I don't have a tool that goes that down to a measurement that small or that narrow. So I'm going to highlight the entire column, and I'm going to click this little decimal place, decrease decimal place button. I'm going to go down to 1, and it automatically rounds everything in the column to match the uncertainty that you have here. I could also stretch it out if I really wanted to. If I had something that was super, super precise and measured down to like the nearest 100,000th or the nearest micrometer, I could do that. But I don't have a tool like that in my science classroom. So just make sure that the uncertainty you have in your column heading matches the number of decimal places you have down here in your cells. Right, so this is my independent variable. I'm going to come down here to my data set. I was also then looking at the starting velocity, in other words, how fast the cart was going when the crash began, and how fast the car was moving at the end of the collision. Right, so that's my U and that's my V. I've already shown you how to format that, so I'm just going to paste those there, right? And then I'm going to bring all of that data in from my measurements. If you're using something like the Vernier motion sensors, you can actually extract that data directly from the app, whether it's a desktop or a phone app. But you can pull these numbers directly from your probeware, okay? So I now have my U, I have my V, and I know that the next thing I'm going to calculate is the delta V, right? The change in velocity. And because my velocities were all measured to the nearest thousandth of a meter per second, that's going to be the same unit of measurement I have in the change in velocity. So again, I highlight that part. I'm going to make it so that there you go. Right. Now, spreadsheets are great because they do a bunch of math for you. So you don't have to go through and crunch all of these numbers. You're simply going to type equals, and then you're going to take your final velocity, the ending velocity, and you're going to subtract the beginning velocity. And you can hit enter. And you'll notice the spreadsheet gives you this little option. It says, do you want me to fill this in for all of the other ones? If you simply click yes, it's automatically done those calculations for you. So no matter what you put in here, it will do the calculation for you. If you go back and you realize, oh wait, this was wrong, right? This was actually negative 1.15, or it was positive, it changes that value here. So it changes your calculation for you. It's a lovely, lovely result of using computers. Okay, here we go. Now we've got our delta V. I also have a beginning time and end time, and I want to measure the change in time because I'm looking at an impulse. This is our impulse investigation. I'm trying to figure out how long the collision took, how big of a difference that crumple zone made in the length of the condition. So again, I set up my column heading showing my uncertainty. Then I'm going to bring in all of my data right here. Right? You might have to hand copy it in if you kept it in a notebook. If you set up a data table on the computer in advance, that's fabulous, right? And so now I've done the same thing with delta T as I did with delta V. If you'll notice, if I click this up here in the window, it doesn't show me that number. It shows me the formula that was used, right? So here you go. I've got that part of the data table set up. This allows me to assess or measure the change in time and the change in velocity, because those two things I get from the motion sensor. Right? Those will allow me to calculate the impulse. So now I want to know what the impulse is, what the acceleration is, and what the force involved in each one of these trials are, so I can start to look for patterns in my data as a part of my analysis and evaluation. So again, I'm going to copy those into my column headings right there. So now I'm going to have the acceleration, the impulse, and the force. Right? The acceleration is simply the change in velocity divided by the change in time. So here I'm going to say equals, take the change in velocity, or delta V, and I'm going to divide it by the delta T, or the change in time. Notice what I've entered here is a formula, equals, and I just clicked on the two cells. Then I'm going to hit enter, and just like it did before, it's going to give me this suggested autofill. So I select, yep, that's what I want. And now, based on all of the numbers that I put in here from my motion sensor, it tells me what the acceleration is. And if you notice down here where I've got a bunch of zeros for my delta V, it can't do the math because you can't divide by zero. Right? In this case, I only had 19 trials, so I'm simply going to delete those rows because I don't need them. All right. Now, I'm going to get rid of this for a moment. We're going to get rid of that. We're going to come back to those correlations once we get all of this in here. Right? The impulse, right, is the change in momentum. That's mass times the change in velocity. It's not about the mass times the acceleration, that's the force. It's the mass times the change in velocity. So here my impulse is equals mass, and I use the asterisk, shift number 8 on the keyboard, And then I want to have it measure or use the change, not the change in time. I want to use the change in velocity. Again, I hit enter. It gives me the suggested autofill. I say yes. Now I have my impulse for all of my trials. And then similarly, because I want to know the force involved, force, according to Newton's second law, is mass times the acceleration. I'm going to take that force, I'm going to take the mass, and I'm going to shift number 8 to get my asterisk. That's the mass times the acceleration that I just calculated. I hit enter. It's going to give me the autofill, and I do that. Now, all of my math is done for my basic data processing. Right? Here are the results of my experiment. Right? This column right here, the crumple zone, that is my independent variable. Right? Delta t, the change in time, this is my dependent variable. Right? These are things that I measured directly. Then I have these other things right here, these 3 columns, the acceleration, the impulse, and the force. These are all things that I'm also considering. Right? I want to know how they're connected to changes in the crumple zone as well. Right? Well, how do we figure out how they're connected? That's where your correlations come into play. So, how are you going to set up your correlation? What you're looking for is the strength of a relationship between one of your variables and another one. So let's come in here, and what we're looking for is I want to figure out what the correlation is between the change in time and the depth of the crumple zone. So in this cell, I'm going to hit equals, and I'm going to type in CORREL, and you'll see it gives you a suggested formula that says Pearson product moment correlation coefficient. This is what you want. It's like, great, I want the correlation, and then it's like, well, what do you want to correlate? The things you want to correlate are your 2 variables you're looking for a relationship between. So I'm going to highlight all of the cells right there with all of my data for my independent variable. And it gives me that range, C2 to C20. Then I hit comma, because that's the first data set. The second data set is my dependent variable here, which is the change in time. I highlight all of those cells, and then I simply go shift bracket or shift parentheses to close that, and I type enter. Boom. What that shows us here, this correlation, is a measure of how strongly related those 2 variables are. The closer this number is to a +1 or a -1, the stronger the relationship is, the stronger the connection. The closer it is to 0, the weaker the connection. So this correlation coefficient, 0.848680, is much closer to -1 than it is to 0. So this is a pretty strong relationship, right? And because this set right here, because this data set is done to 2 significant figures, this one is done to 3 significant figures, and so is this one, right? We're gonna limit our correlation to 3 sig figs, right? So I'm gonna take this cell right here, I'm going to come up here and I'm going to change it. I'm going to bring it all the way down to give me those 3 digits right there. 0.849, boom. Now I've got 0, I've got that. I want my 3 sig figs, okay? So it's doing the rounding for me. It's not going to make any mistakes. And you see this little blue circle, this little blue dot on the corner? Right there, if what I want to do is that I want to look for the correlation between the acceleration in the crumple zone, the impulse in the crumple zone, and the force in the crumple zone, I'm going to run the same calculation. So I'm just going to drag this over here, right? And we want to, let's see, these patterns are really different. I wonder if that actually worked. So we're going to check it. It's looking for a correlation, but look at this first data set. It says it's D. D was not one of our independent variables, right? So here, instead of D2 to D20, I'm simply going to change this to make sure that it's still there and hit enter, right? So right here, I'm going to change this from D, I want it to be C to C. And then the correlation is with J, that's the acceleration, that's actually what we want. So I'm going to hit enter. Okay. Notice the difference here. Here's your correlation. It says that the change in time has a really strong negative correlation or an inverse relationship, but there's a weak relationship between the acceleration. What about the time? I'm sorry, what about the impulse? So again, I'm going to type in correlation, open my brackets, and I want to see the relationship between the thickness of my independent variable, that's the crumple zone, and the impulse that's experienced during each trial. And what does that give me? A really, really strong relationship. The strength of these correlations, these really allow me to then do a nice analysis and evaluation of my data that I'm going to put in my lab report for that criterion C aspect of your MYP. I hope this was helpful. Thanks for watching.